is going to be focusing on adding and subtracting today. So the biggest thing with adding and subtracting, personally, I like multiplying and dividing because it's easier. It involves factoring. But for this stuff, you have to kind of go back to a little bit of like remedial math. So like this is like looking back at like 4th grade, 5th grade math. So recall, you don't have to do this one on your notes, but think about it. We have 2/3 plus 3/5. So when we do that, what do we need to do? We need to find a common denominator, okay? So if we look at 3 and 5, we have to think, well, what would be the common denominator? Which would be 15. Then to get the numerator, remember we would think, okay, 3 times what makes 15? Which would be 5. Then there's a 2 up there, so I have to multiply that 2 by 5. And so this would be 10. And then for the second fraction, 5 times what makes 15, which is 3. And then I got to do 3 times 3 because there's a 3 already in the numerator. So that would be 9. And then hopefully you remember, what do we do with the numerators? So we add them. And then remember, we just keep the denominator. We don't add the denominators. And we're just going to leave it as an improper. So do you remember doing that back in the day? This is the same stuff, guys. All that's different is that we're going to put letters in there. Okay, so it's just kind of kicking up 4th, 5th grade stuff up a notch because we're putting letters in there. So we're still going to start out with the same approach. Find a common denominator, multiply by what we need to, and then again put things together. So if we have 10a and 5b, we have to think, what would be our common denominator? 10ab. So I like the 10, yep. So it'd be, we need the letters, so 10ab. Okay. What we have to do is look at the 10a. What do I need to multiply it by to make it now become 10ab? Because right now it's 10a. We need to multiply it by b. So I'm going to do 9 times b, which is 9b. So is everybody okay why we put a b in the numerator? Because we had to get 1 multiplied in the denominator, so then I need to multiply b in the numerator as well. Okay, then for 5b, I got to think about, what do I need to multiply that by to make it become 10ab? 2a. I need a 2a. So I'm going to multiply the numerator by 2a. Okay? So therefore, we're going to do 4 times 2, which is going to be 8. And we're going to have a times a, which is going to be a squared. And then from there, since we have a common denominator, we can put them together. So when we put those together, then we can say, I can write it in alphabetical order, or I could just write 9b plus 8a squared over 10ab. And then nothing matches in the numerator, so I'm not going to go any further with that. So that's my answer. If you can factor something out, then do that, and then you can cancel. But remember, we can't just directly cancel things when there's a plus sign or a minus sign involved. And so that's the answer to that one. Okay. All right, number 2. So think about, what would be the common denominator for that one? So common denominator would be what? AB. Okay, do I do anything to my first numerator? No, because it's already fine. So we're not multiplying the denominator by anything, so it stays the same. Next, what do I need to multiply this by to make it become this denominator? A. So we need to multiply this by a, so then this is going to become 9a. And then put these together, but they're not like terms, so I'm just going to write 7 plus 9a, or I could write it as 9a plus 7, and then keep the denominator. And again, not all the terms have an a in it, so therefore this is it. I can't do anything more. I cannot cancel that a with that a. That's illegal. Okay. Questions so far with adding and subtracting? Okay. Yeah, I know some of the ones coming up are really exciting. So that's true. Okay, number 3 isn't so bad. They don't get really cool, I think, until 4, 5, and 6. So for number 3, what would be your common denominator? 10a. So part of, again, for your, steps is always to think about what would be the common denominator. So then we have 10, not 10a. So what do I need to multiply the numerator and denominator by? An a. So this would be 11a. If I go to the second fraction, we got to multiply it by 5, right? So 7 times 5, which is 35. And then finally, I've got 5a, but I need to turn it into 10a. So I got to multiply that by 2, so I got to multiply this by 2, which would be 12. Okay, put these together, and there's subtraction, so I'm just putting subtraction symbol there. And then again, put together your like terms, so I have 11a minus 47 over 10a. And again, not all the terms have an a, that's subtraction. This is my final answer, I'm done. Okay. Now, where they get a little bit more interesting, it's dealing with the denominator. So the denominator is going to become a little bit harder, but not too bad. So like for this particular example, do you see how these are uniquely different? It's kind of like that bad analogy I was using when we were doing trig identities. Like this is dog, this is cat, so then the common denominator was dog, cat. So for this one, your common denominator is going to be both these expressions. So we need to put that with parentheses just because we need to distinguish each one from each other. Okay, so that's going to be our common denominator. So if the common denominator, if they're two unique different things, then you just put them both in parentheses down in the denominator. So we're going to be multiplying a little bit more. So this x plus 2 is going to stay, but what did I multiply the denominator by to make this? So hopefully you realize I multiplied that one by this, so I need to put an x plus 1 in the numerator. Okay, and I need parentheses around that. And then for this one, I originally had an x minus 3, but then think about what did I multiply this by to make this? So I put in and multiplied by an x minus 1, so I need to put multiply by an x minus 1 in the numerator. Okay, what's your hunch? What do you think we're going to do next? No, we can't subtract yet. We will eventually. We're going to distribute, FOIL, hashtag, whatever you want to call it. So fun things that we get to do again. So we're going to do x times x, and then x times 1, and then 2 times x, and then 2 times 1. So that's multiplied out. So these get a little bit nastier because of the algebra that we'd have to do. What do we need?
No, you're good.
Okay. And then the next one, we're going to multiply that out too. So x times x, x squared, x times negative 1, negative 1x, negative 3 times x, and negative 3 times negative 1. So again, lots of polynomial skills coming back. And most of you guys, I think, liked the polynomial chapter. If I had you first semester, most people were like, hey, this isn't so bad, you know. Okay, anything I can do with these numerators before I subtract? Because you guys said we should subtract. Yeah, put together some like terms. So this is x squared plus 3x plus 2. And this is x squared minus 4x plus 3. Now be careful. If you're subtracting, I'm subtracting all of that. So that's going to mean, like, I'll show you. I'm going to put the minus, but then I'm going to put this in parentheses because I'm going to try to remind you that you need to distribute this minus through or you're going to get the wrong answer. We don't want that. So we don't want you to have the wrong answer. So when I multiply this negative 1 through, I'm going to get a negative x squared, a plus 4x, and a negative 3. So what do we notice about the x squareds? They drop. So this is gone, this is gone. 3x plus 4x is 7x. 2 minus 3 is negative 1. And this isn't any like terms, so we're good. So the denominator just comes back in. And that's my answer. By the way, what values would be bad for x?
0.
Not 0. 1. And -1. Okay. Ben, your question. No, I would not. You could, but there really isn't any purpose to doing it, so I wouldn't. Okay, the last two examples, be careful. Sometimes when we have denominators that like are not factored or they might have something in common, it's hard to know what we need to multiply the numerators by. Like if I would originally look at that problem, my hunch would be just doing the same thing I did before, dog, cat. But there's something wrong with this guy. What do you notice about him? You should be thinking GCF right now. What's in there? A 3. So when I factor out a 3, I get this. So, right, that's why I factored this. So you can figure out the common denominator is not going to be x plus 2 parentheses 3x plus 6. It's really just going to be 3 parentheses x plus 2. So there's a purpose to doing that. So when you have a denominator and you're not sure like what possibly is going to be the common denominator, if it can be factored, factor it. So that means this right-hand fraction will not change. Okay, then for the other fraction, we are missing a 3, so we're going to multiply the denominator by 3, so we're going to multiply the numerator by 3. So that's going to become 9. And then put together your like terms. So I'm going to have 4x plus 14, and then 3 parentheses x plus 2. So I could, by the way, factor the numerator here, but it's not worth doing because you just take out a 2. You wouldn't get anything to match. So that's my final answer for that one. Yes. What would be the bad value for x? No.
-2.
-2. Right. Okay. The last example that we have, this is probably the hard part. So you need to know what is this because it can be factored. So what would it be?
1.
This is factored to be a plus b, a minus b. This is called the difference of two squares. This is going to help us now because now I know what is the common denominator. It's going to be a plus b, a minus b. So now I know what I need to put in there. So for the numerator, this one's fine. For the denominator, I multiplied by an a plus b. So I'm going to have a 1 parentheses a plus b. And then multiply through. So I'm going to have this, well, let's put this as a -1. That'd be easier. So -1 times a, which will be -1a. And -1 times b, which will be -1b. And the denominator will stay. And then these are like terms. So we'll have 6a minus b over 6a plus b, or pardon me, a plus b, a minus b. And then that's my answer. I can't cancel anything. Okay? So questions on that? Okay.